You didn't log on before time, like you said.
Last night. Yeah, it's because I didn't get the TV.
All right, now I do remember, Mr. McFadden asking me at one point if we were having homework over spring break, and I think I said no.
Yeah, how'd that go?
Well,
I had homework for this.
but then the idea was that this was for, this was on that Thursday, we took the quiz, and after lunch, you had time to work on it, which was plenty of time. So to me, you didn't write homework. But then again, if you were track, and you're at the track meet and stuff, so I'm not gonna pick on it, but, and then you went ahead and did it, right? Or copied your answer to it. So don't have to panic. But anyways, they're one of those that, just because it has been 10 days, that we could look at as just a quick review, or have any difficulty setting up. What was one, do you remember? Maybe you don't even remember this worksheet. 4. Number 4.
Yeah, it was hard to set up.
Bill.
Can we get our test back, or?
No,
Somebody else did.
because some people forgot their shorts at home. Various.
That's so.
Corbin did talk to me, but we
Oh yeah, by the way, I'm gonna be missing you again sometime this week because I need surgery.
Okay. All right. So.
And then meet another one next year.
So we don't get to see those. No, so yeah, we need to get those taken care of tomorrow, and then we can get those back. And then, or today, you said today, 4th, and you said tomorrow morning. Okay. So we can get those taken care of, we can get those back, because we are going to have we're going to have another grade enhancement opportunity this week. Grade enhancement opportunity. Of course, it's also a opportunity for your grade not to be enhanced, I guess, also. Depending how you do. But let's look on the bright side. It's a grade enhancement opportunity. So really, we're not going to do much more of chapter 6. Actually, the first 2 sections, chapter 6, is what we're doing. Then we're going to jump to chapter 10 on Thursday. So there's a chance I won't be here. Supposed to have a track meet, but the way the weather's looking, may not have a track meet. Doesn't look good. So anyway, so if I'm not here, Mrs. Payne, you'll get the opportunity for Mrs. Payne to introduce you to chapter 10. Although I'm a little nervous about that, because you may want her back every day. But so anyway, so we're just going to finish up. So we've got some stuff to finish up in section 2. Today we'll work on. Tomorrow we'll kind of probably, with spring break being in there, probably don't want to do it tomorrow. So probably do it on Wednesday. Okay, so we'll take tomorrow to spend some more time on some story problems, law signs, law cosines, right? Try to remember what we did 10 days ago. So do an activity tomorrow, maybe with some of that, and review those things. And then on Wednesday, I'll just call it another quiz. You could call it chapter 6 test, whatever. Just going to be, so basically a few more story problems probably, though. A little bit of law signs, law cosines, and then the new thing we're going to add into today. Okay, and then we'll move on, be done with kind of the trig stuff. So number 4, just the setup of this thing. It says, Bill determines the angle of elevation at the top of the building is this. If he walks closer, the new angle of elevation will be this. Find the height of the building. So angle of elevation, remember, is always from the horizontal, so that would be looking up like this. So this would be 40 degrees, 30 minutes, which would be 40.5 degrees. If he walks 102 feet closer, so if he goes this far to right there, then the angle of elevation would be 50, and what is that actually, 0.3, repeat, 50 degrees, 20 minutes. And then that angle of elevation will assume the building is straight up and down, so it's a right angle. Find the height of the building, so we're looking for this side right here. Okay, so you could just do, if you knew this side right here, then that would be, you could just do a SOHCAHTOA with this part, right? Or I guess if you found this part, then you could do do something with that as well, with the big triangle too. But basically, if we could find this, right? Now, I think we can because we know this angle. If this is 50.3 repeating, what is this one over here? How would we find this one? Subtract from 180, right? So that's going to be like 129.6 repeating, I think, would be that one. And then take those two, add it up, and you could get this one, right? But we don't need that. This is well, yeah, we do, because our 102, we're going to need to do that angle. So let's go ahead and do that. Or tell me what is that? Maybe somebody have it. How much? That's rounded probably, isn't it? 9.8. We did say rounding the angles is not a huge deal. It's the sides. If you round them early is probably a bigger deal. So rounding this is probably not as important. So now we can do a law of sines. We can do sine of 9.8 degrees over 102, and then sine of 40.5 over x. So now we can do that. That would find x. Remember we talked about not rounding that, or at least saving in your calculator or writing down in your paper 5 or 6 decimal places. But once you find x, now you could come over to the red triangle, right? And now you can just do opposite over hypotenuse. So you can do sine of 50.3 repeating is equal to h over, and then whatever you had for x. Whatever you got when you found x over here. And again, I would carry out multiple decimal places. And then all you have to do is multiply that over there. I have the answers. So yeah, so I like 388 something for this one right here. 388 point whatever. And then 298. So the answer for this was like 298.7. Okay, so you put your 388 down here and just multiply. All right, so let's go ahead and actually do have a lot of work time for you today. A couple of formulas to do. Let's do just a quick warm up here. I don't want you to work these. I just want you to look at these and say, would you use law of sines to solve this? Would you use law of cosines to solve this, or neither? Can you not even do it? Can you not solve it? So law of sines, law of cosines, or neither. Okay, so the first one is, so how I would look at this. So this is something that, the last quiz was mostly, doing work, right? Doing law of sines, doing law of cosines, solve the triangles, a few story problems over there. So I may ask you some more questions, still do some of that, but it may ask you some questions like this, right? Which one would you use? Or how many solutions are there? That kind of thing. Where you just have to discuss or just know about, law of sines. You use that little cheat sheet on law of cosines again if you need to, but the rest of it you'll have to know, including we had some formulas today. You'll have to know those. But so anyway, angle. There is no solving a triangle. That could be an infinite number of triangles, right? You could have a little tiny one, a little big. There's this triangle. Well, this triangle right in here would have all the same angles as that one, but it would have totally different sides. And so you can't do anything with angle. So that's a neither. Okay, this would be a side angle. An angle, but you don't, and the one across from it. That's always going to be a side angle, right? If the only other one where we only know one angle. Remember, if we know 2 angles, then we really know 3 angles, and we know one side. We can always do law of sines because we'll always know a side across. But if we only know one angle and we know the side across, and then another side, that's going to be side angle. That's going to be your ambiguous case. But you would use law of sines on that. Number 3 is that all 3 sides you do law of cosines. If you know 2 angles, it's law of sines every time. So angle side angle or angle side, either one of those would be law of sines. Here's a side angle side situation. So when you know one angle and you know the 2 included sides, then you're going to do log cosines, right? Then you're going to do log cosines. And those are all ones that are just going to have one solution, one triangle that can fit that data. And so you will find what, the rest of the stuff, and you'll be good. And then, of course, the last question, which one was number 2? This is the ambiguous case one. When you're given this, it might not be a triangle. It might be 2 triangles with that information. Or it might just be one with that information. And we can talk more about that tomorrow. And review that again before our quiz. Okay? All right. So for your notes, why don't you go ahead and get your notes out. So this slide is just what we were just talking about there. So side angle side, we're using log cosines. 2 angles, if you know 2 angles, you're using log sines, and of course the one with the weird one, side angle, we're doing log sines. So the question today is, what we want to add to this is the idea of the area of a triangle. The area of a triangle. Okay, so we know that if we have a right triangle, so let's think about the different types of triangles. So we're talking about finding the different parts of a triangle, the different sides, the different angles. Given some parts, find the other parts. So another thing we would often do would want to know the area of a triangle. Another thing you might want to know is the perimeter of a triangle. I mean, you think about your work in geometry with squares and so forth like that. You would talk about area, you would have area formulas. You also have your perimeter formulas. Perimeter is easy, it just add up around. So that there's nothing really to be done there. So area, how do we find area? Well, we know from geometry class we can do area this way. A right triangle, of course, is easy. That you got the base and the height. So it's just 1/2 base times height. So right triangles are easy. Now remember, what's oblique mean? What's an oblique triangle? I said it like one time, and so that's probably going to go. What's an oblique triangle? Okay, oblique, so this would be a good time to put it. Oblique triangle is not right. A non-right triangle. Okay, so any other triangle besides a right triangle. So I guess you could say it's an acute or an obtuse. That's why I drew 2 of them. I drew an acute and then I drew an obtuse, right? And of course we have scalene and isosceles and equilateral. That just depends on whether your sides are equal, how many sides are equal, that kind of thing. Okay, but there's right triangles, there's obtuse triangles, there's acute triangles. So I got all 3 here, but these 2 are called oblique, right? Non-right triangles. Okay. All right. So if you have an acute triangle, then the the altitude, the height, is inside the triangle. And if you have an obtuse triangle like this, then the height may be outside of the triangle. Now you could, if this was your base, you could have your base over here, and then your height would be in there, right? I mean, so if you're drawing the height at the obtuse, where the obtuse angle is, your height could be actually outside the triangle. But that's how you would calculate areas. But the problem with these last 2 is you have to find some other piece of information that is not a part of the triangle, right? H in these 2 cases is not a part of the triangle. So when we're doing law of sines and law of cosines to solve these triangles, we're not finding this H. We're not finding this here. Now over here on the right we would, of course there we would use Pythagorean theorem and so forth. But it's the H is not part of the triangle, so it gets difficult to do. Now it's not impossible to do. You can figure it out, especially with some trig, right? With some right triangle trig, you might be able to figure those things out. Okay. Well, let's use that actually to do that. So the question for today is, if I had a non-right triangle, right, either an acute or an obtuse triangle, how could I figure out the area of those? Okay, so we're going to work through this together here. This is something else I borrowed from Mrs. Payne. So ignore the homework stuff down there at the bottom, because this is from long ago. This is from a whole different book. That's not where we're going to be at all. So you can skip that part. But so the front side of this Okay, so if we started with an acute triangle like this, okay, and as it turns out, it's not going to matter whether it was an acute or an obtuse, but it's just easier to show in an acute triangle. So I've got it labeled A, B, C, all these different parts. We're going to use K. A lot of times the books use, for whatever reason, they use K for area because we're already using A as one of the sides. You know, ABC is something we often use for one of the angles of the triangle. So we don't use A for area a lot of times when we're doing these triangles now. So they're using K. And we know that it's 1/2 base times height, right? We know that. Now, what is sine A equal to in this picture? Sine A would equal what? H over C. Right? Correct? Sine A would equal H over C. Now, what could we do with that? What can we do with the H over C? Equals sine A. In other words, solve for H. Because what I'm trying to do is create a new equation where I don't have H in it. Remember the problem, what we were talking about earlier, is the problem here is that H is not a part of our triangle. It's in the triangle, but it's not one of the pieces of the triangle. So I'd like to get the H out of there. Well, the way you get H out of there is you substitute an equivalent thing for it. So by solving for H would mean to do what? Multiply the C over to the other side. So wouldn't it be true that in this triangle, H would be equal to C sine A? Now, we actually did this when we were doing law of sines, right? Think of this H as being the swinger. Think of like A. Remember how we did that? Like sine A here would be the swinger. Now, we did B sine A. We called this B up here. So it was actually B sine A, not C sine A, right? When we were trying to determine how many solutions. So if A was like the swinger, when there was one solution was when A was equal to this height, right? And what was the height? B sine A, right? We called the height B sine A. So we kind of already know this, right? We already used this fact before. Well, now look what we can do. We can take and substitute that right there for H. So a new formula for the area would be 1/2 B times C sine A. That makes sense? And so look what you would need then. What that means is if you knew the angle and the two included sides, in other words, how do we abbreviate that? What would that be called? Side, angle, side. If you know side, angle, side, if you know two sides and the included angle, you can find the area very easily. It's just 1/2 this times the sine of that. Okay? Now, I say very easily, it would have been about the same number of calculations to do it anyway. You know, how would you find H? If you knew these three pieces of information, how would you find H? Well, you'd do the sine of A is equal to H over C. You'd find H. Then you would do 1/2 base times height. You'd have two formulas to basically do. So all we're doing here is using those two formulas, combining them into one to give ourselves a formula we can use. Now, a year from now, will you remember that? Or will you just do area is 1/2 base times height? Who knows? You know, probably just do that, which is fine. So in your little thing here, you can put, these would be formulas. Now, it would work the same if we had these other ones known. So what do you suppose would be an alternate form here? 1/2 what? Just like law of sines, we can do it with any of the different angles and side combinations. So 1/2 AB sine C, or the other one, 1/2, which one haven't we done yet? AC sine B, right? Because if it's the two sides of the included angle, they're going to be different letters, right? Because you're going to have C and B with angle A, you're going to have A and B with angle C, and you'll have A and C with angle B, would be the side angle side combination, right? You won't have the one across. What's that? Wouldn't matter. Because you're multiplying. So A times C, C times A. I always just put them in alphabetical order. Okay? Yeah, since you're multiplying, the order doesn't matter. Okay, so those are equivalent. But basically, it's side, angle, side. So if you've got side, angle, side, That's what we do. Okay? So, let's try those two problems real quick. Just write down your setup, and then write down, your setup, your work, use your calculator to calculate what you need. And you can talk it over with each other if you need to.
I know. I hate myself too.
I'm not gonna trust it.
You'll still be there.
I don't have to trust it.
Oh yeah, are you ready to take the writing test?
You don't have to.
We don't have to?
It costs extra, it's optional.
God, I don't want to.
The writing test is optional.
Wait, I don't think.
I
No,
think
they're
it's
making
optional.
it, pretty sure they're making it.
I'm sure we have to.
Usually it's optional.
Are we supposed to write about our feelings? Like,
Yeah,
Give you
please
the-
test, please send me home.
Mr. Coulter was gonna get on his road.
Good thing it's
I
not.
don't give a fuck, you're sad for the rest of it.
Once upon a time, it was so sad. A sad story.
Charlie, be that kid that writes, I have stuff
I have party bound, why do I care?
Oh yeah, do that. Charlie, just draw out the picture of the guy and had to do it to him. Just do that. Nothing
If you're
else.
reading this, can't do that.
Oh, Charlie, you gotta draw a doctor with you. It's like, there's a platypus controlling me, I can't stop.
And his two angles,
Son, we saw your writing test. We lost Carney down, I'm sorry.
It gave me one side and two angles. Oh.
Okay, what's different on number 4?
It's obtuse.
Right? But that doesn't really matter as far as the setup.
Gives you two angles.
Gives you different information, so how does that affect things?
You have to do an extra step.
you have to find some more information, right? I mean, in other words, what is it we just spent the week before learning is how to find all the missing parts of the triangle, right? What do you need to be able to use this new equation we just learned? Side, angle, side, right? You need side, angle, side. And so you have two angles, you have only one side, so you need another side, right? So find another side, right? You know how, right? You know how to find, you could find all the missing parts of that bottom triangle if you had to, right? Now you don't need all the missing parts, you just need enough that you can do the new area formula that we just learned. All right, let's take a look at this. Oops. So the basic scenario is that we have, we're looking for side angle side to use this new area formula that we have, okay? And so it works really nice with this one. So we simply, let's use K. That's be a good habit to get into. Time, it doesn't matter how you write it. Like I said, it's all multiplication, but don't get the. And then so it would just be 16.5. You put that in parentheses, not a bad idea. 21.2, and then times sine 25. So when I say show your work or show your setup, I'm just saying I want to see that. And then, of course, you go to your calculator and get your answer in. What did you have there?
Which you times by 1/2.
Oh, yes, and 1/2, and then the 1/2 out in front. Yes, I forgot that. So, hang on here. I think I got that. 73.9, something like that. Okay. Now, on this one, you're going to need to find this angle up here, which turned out to be what? 40, how much? 41.6. Okay, so now you got all the different angles. So now it's up to you which side you want to get. You want to get this side or you want to get this side over here. Okay, it doesn't matter. You've got the angle in between. And maybe you could argue you didn't even need that, right? If you're going to get this side here, you could have just said, okay, sine is 27.3 over L is equal to, well, yeah, you did need that, didn't you? Because the other side you had was 45.7, so you were going to have to find that 41.6 over 45.7. Okay, so L turned out to be 31.57 something like that. Okay, so if you get 31, again, it would be good to carry that out however far. And then now you can set up your 1/2 31.57 times 45.7 times sine of 111.1 degrees, right? And then final answer, 670 something, 73, okay. All right, and so that's it. I mean, using what we learned, law of sines, law of cosines, potentially law of cosines could come into play, but find whatever pieces you need to then let you use the equation. Okay, let's flip that over to the back side. And here just is a formula I'm just going to give you, and then we're going to work on some book problems here for a little while. And to be honest, you can just put them on this worksheet, or you can do them on the back of that other worksheet you had, the law of sines worksheet. Just some practice here till lunch, doing both of these. So this is called Hero's or Heron's formula. I've seen it both ways in her book. It's Heron's. That's how I've typically seen it, to be honest. But I think at some point it just got mistakenly called Hero's formula, and so so sometimes you'll see it referred to that. And we're not going to derive this one, so this is just one you're going to memorize. It's pretty simple, actually. And the key is S is called the semi-perimeter, which is just add up the outsides and divide by 2. So this is what you would use if you had side, side, side. Now, if you had side, angle side, you could use, it'd be silly, I don't know why you would, but if you had side, angle side, you could use law of cosines to find the third side, and then you could use Hero's formula to find the area. But if you have side, angle side, that other one we had works way better, much faster, you'd just be done. So it would be silly to do that. But, or you could say if you had side, 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 you could use law of cosines to find one of the angles, And then you would have side angle side, and you could use that other area formula that we learned, okay, that we just had on the other side, okay? But the idea here is, if you got side, 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 here's an option, okay? So what is it? It's a square root of, and then it's the semi-perimeter, and then you take the semi-perimeter and subtract each of the three sides, okay? So to do this one together down here, if I had triangle ABC, so I don't know if you want to just hang on to this worksheet or you want to transfer that into your notes maybe, it's up to you. But if I had A is 24 and B is 52 and C is 39, the first thing I'm doing is finding S. So I'm going to add all those up. Okay, so that's going to be 76, 115 divided by 2. And so I get, what, 57.5. Did I have those right? Okay, so S is 57.5. So my area is going to be the square root of, and this is the part I want to see written out, 57.5, and then it would be each of these sides subtracted from 57.5. So it would be 57.5 minus 52, which would be 5.5. It would be 57.5 minus 24, which would be 33.5. And it would be 57.5 minus 39, which would be 18.5. I think I did that right. So again, when I say, show your work or your setup, I want to see that written out. Now you can just go to your calculator. Be sure you're careful with your parentheses and stuff inside the square root when you do your problem. Okay, so pretty simple. Not too hard to remember either, I don't think. And then 442.7. And what would this back? They didn't even give us in units, but if it was inches or something, remember area would be squared inches. You get something like that. Okay. All right. So let's do, I've got a handful of problems for you to do here in your book. And then we're going to do a worksheet we'll get started on at some point after lunch. So on page 434, so this would be the first one that we learned. Hang on a minute, let me see which one's for sure. Okay, so we've got 5 problems here to do. Okay, if you want to put those on the back of that law of sines worksheet, that's fine. Okay, so they're all just area, right? They're just using the 2 formulas that we have now got. I should say, we kind of want to keep, if your problem is in decimals or whole numbers, it comes out decimals, decimals are fine. Once we use sign and those things, you're going to have decimals. When you get to the one with fractions, you should use fractions. Your calculators will do fractions. You should keep it in fractions as long as you can. Now, eventually, when you do the square root part at the end, it's going to turn it into decimals at that part. But that's the best way to keep, the exact answer, or a better, more accurate answer is if it's in fractions, keep those in fractions as long as you can. When you get the other three on the other page done, come up here, show me your answers, and I'll give you your